of gappiness to determine the textures in welds. Here we have feature extraction based on a very coarse rendition of a window with a weld that has been supplied to us. And what we do with these features is we plot them in a feature space. This is the Hausdorff-Besicovitch dimension, which has been scaled to work with pixels in the feature space along with standard deviation, another common measure of texture. We plot these things and we can show the centroids of the plot using the Kmeans algorithm, which we can demo a little bit later. And this results in a segmentation which isolates the area where the weld exists, and it gives us a fairly clean mechanism for doing the weld feature extraction. So what we can do here is we can change the resolution at which we devise the feature extraction in some arbitrary way, and in fact we can get very fine in doing this. And next scene will show how we can do clustering with large numbers and we'll animate it to show the algorithm. Here we're going to demonstrate the clustering of 16 million different feature points into 8 different categories, and the computer adjusts the segmentation and centroids of the different partitions until it's able to arrive at a clear identification based on the arbitrary feature space. Right now we're working with a two-dimensional feature space, but in fact we could go to many higher dimensions, and naturally the curse of dimensionality will cause the algorithm to slow down quite a bit. Here's an example where we have 1 billion feature points and 3 classifications, and what happens is because there's so many feature points it looks like a continuous image, but in fact they're individuals. And what we can do to demonstrate that there are individuals is crank down the number of features and see if we get an approximately similar solution. So here we'll just do 1 million feature points, and we can see that the solution looks approximately similar, and it converges much more quickly as a result. Here we see a three-dimensional rendering of the image weld in a RGB color space. The size of the spheres is directly proportional to the number of pixels of that specific color, and it's clear that we have a mechanism in place now for doing clustering, but if we want to do the clustering in 3D, there are some clear clusters that we could use, and this might hold some promise for the future. Thank you.